Our first step is to configure our Redux store for production. Our current store that you see here contains a code that we don't want to use in production. See, Redux immutable state invariant is only really useful for development. It would cause performance issues and is really just there as development warnings that should occur when we accidentally mutate state. So in order for us to create a store for production, we need to create a separate configure store call for both development and production. And here's how I'll do this. I'm going to rename configure store to configurestore.dev.js. And then I'm going to copy this file and we'll paste a new version of it and we'll call this configurestore.prod.js. Now that we're creating a production version, there's only one difference in the production version that we don't want, and that is Redux immutable state invariant, because that's only really useful for development purposes and would just slow our app down unnecessarily. And that's really it. So now that we have our dev version and our production version that are slightly different, the question is, how do we put each of them to use? For that, let's create another configurestore.js file. And inside of here, we'll just call configure store based on the node environment that is currently set with a simple if statement. So great, now when we deploy to production, our application will use the lean simple store that we have created that contains production specific concerns. And now there's one final tweak that we'll need to make given this change. We're no longer defaulting export from this file, and our linting rules expect us to export default from each file. So we'll need to come over here and place where we're consuming our store, which is of course in our application's entry point. And then at the top of this file, we'll need to put in a ESLint disable for our import default rule. This way, ESLint won't complain that we're using a file that doesn't have a default import. Now you're probably wondering where the node environment gets set up. So we'll take care of that in the next video as we configure Webpack for production. We already have a development Webpack config. Our production configuration will be very similar but different in some key ways. So let's begin by just copying our Webpack config and creating a new file, which we'll call this webpackconfig.prod.js. And there's only a few things that we need to change here. So let's start from the top. For our dev tools, we're going to use the recommended production dev tool, which is SourceMap. So the reason that we use this is because it's a bit slower, but it's more thorough and it's more recommended for production. The second thing that we need to change is our entry point. Right now we are defining some development specific concerns like hot reloading and the event source polyfill, which are related to hot reloading just to make it run on Internet Explorer. You don't need either of these, and in fact, we actually don't need this array anymore, so we can take that out. We can just put a single value here because Webpack will accept that as well. Now moving on to our content-based changes. We can point this toward dist rather than source now. So that's a pretty simple change. Now we can move our focus down here to the list of plugins. We don't need either of these for production, so we can just take those out for now. Now let's move up to the top of the file for a moment. I'm going to type out a constant here, and we'll call this constant globals. And what I'm doing here is I'm defining a node environment variable that sets React for production. This will end up being passed down in one of our plugins that you'll see in a moment so that React is built in production mode. I'll just type out the plugins real quick and now we can talk about each one of these. The occurrence order plugin optimizes the order that our files are bundled in for optimal minification. The define plugin lets us define variables that are then made available to the libraries that Webpack is bundling. React, for example, looks at the node environment to determine if it should be built in production mode. Production mode omits development of specific features like prop types, which increases React's performance when we're running in production, so it reduces the bundle size. The extract text plugin lets us extract our CSS into a separate file. So this will generate a separate physical styles.css file. We'll also need to reference this separate file in the production version of our HTML, which we'll set up in a moment. One other piece that we need to do next is import the extract text plugin into our page. So I'll add this import here up at the top. The dedupe plugin eliminates duplicate packages in our file bundle to help keep our bundle size as small as possible. And finally, the Uglify.js plugin minifies our JavaScript. We're only running this in production because there's really no reason to run it in dev mode. It would only slow down our build process. And for our final change, we just need to update the loader that we're calling right here. We're currently passing in an array of loaders, but now that we're wanting to extract our CSS, we can just use the extract text plugin right here. And we'll say extract text plugin.extract and pass in the file type that we're dealing with. And then also this query string tells me to generate source map as well. So we'll have a corresponding separate physical file that handles our source map. I'll also change this to say loader because we're only defining one loader rather than an array of loaders. Now that we have our config ready, we obviously need to call it somewhere. So let's do that in a file called build.js, which I'll place over here in the tools. And I'll just paste in the code for this one. At first, it might seem a little intimidating with the amount of code, but let's talk through it so you realize it's not really that much. As you can see, I'm setting the node environment to production here so that the dev configuration for Babel doesn't apply. This assures that no hot reloading related code is included in the production build. Then I write a message to the console so that we know that it's working. This is just a nice thing to do since minification for production takes a few seconds. The real magic happens here. I'm just calling Webpack and then displaying any errors or information that it provides to the console. So as you can see, quite a few lines of code, but conceptually, it's quite straightforward. It's just running Webpack in production mode and displaying the results in the console. And now that we have Webpack set up, let's shift our focus to generate custom HTML files for production. For production, we're generating a separate CSS file, but as you can see here, our index.html file doesn't currently reference a CSS file. And that's because in dev, our CSS is bundled with Webpack right into our bundle.js. So Webpack is actually encoding our CSS into the bundled JavaScript file when we're in development. And that's also why you may notice a momentary flash of unstyled content in development because the styles don't apply until the JavaScript is parsed, since the styles are actually sitting inside the JavaScript file. So we need to modify our index.html file and copy it over to the dist folder as a part of our build. Let's create a simple node script in our tools folder to handle this. We'll call this script build.html.js. And again, I'll just paste in and then we can discuss how this works. We begin by importing fs, which comes with Node and is useful for interacting with the file system. We can also use Cheerio, which I briefly mentioned in the testing module. Cheerio gives us a handy way to interact with an in-memory DOM using jQuery selectors. And we already used the color package in the environment setup module to add color to our console log statements. Then all I do is read the index.html file and I pass in the resulting HTML down here into Cheerio. What Cheerio does is create a handy in-memory DOM that I can query using simple jQuery selectors. So what I do is I get a reference to the head and then add in a link to our style sheet. And finally, I write the results to the dist folder and log a friendly message to the console. So with this script, we'll have an HTML file that is ready for production. You could also do another production specific feature here if desired, like referencing a bug tracker library. So in the next video, let's use Express to serve up the production build running in our local machines. Now, this isn't really required, but I like to run the final production version of my app on my local machine just to make sure that everything looks good. This can be helpful when you need to debug an issue with the production build. So to do this, let's go over to the tools folder and create a new file. Let's call this distserver.js. Now we already have a source server, and the source server serves up the file in the source directories. So the dist server will serve up the files for the dist directory. I'll just paste in the code because it's very similar to the source server. Some of the key differences are I simply remove the Webpack and hot reloading related code since we're just serving up plain static files via Express. And on line 11, I configured Express to serve static files. That's really it. It's really nice and easy. We're almost done here setting up the production build. The last missing piece is to add some scripts in the package.json, so let's go ahead and do that next. To automate our build process, we need to add some npm scripts here to tie all the goodness together. It only takes 6 lines to orchestrate all of this, so I'll paste this in and then we can talk through it. As you can see, we have a pre-build, build, and post-build step here at the bottom. By convention, pre-build will run before all of our build, and post-build will run after build. The prefix tells Node what order to run these scripts in. As we can see in the pre-build step, I'm using npm run all, which is a cross-platform way to run multiple commands either one at a time or in parallel. Here, I'm not passing the parallel flag, so the clean disk script will run, then test, then lint, and then build.html. As you can see in the clean dist script, what I'm calling is yet another script, remove dist, which sits right below it. What I'm doing here is getting rid of all the dist folder and then recreating it. This is a good idea just to make sure that we have a completely clean build so that any old files are removed. I'm using rimwrapped, which is a cross-platform way to be able to remove a folder forcefully. This is really the equivalent way of saying run rm-rf if you're familiar with Unix systems. But since this is a Node module, it will run on Mac, Linux, and Windows just fine. And as you can see, in the clean disk folder right here, after I removed the directory, I recreated. Thankfully, makedir is a cross-platform friendly command, so it will run on all platforms as well. Now that we've discussed clean dist, you can see back in the pre-build, I'm also calling test and lint so that those tests are going to run before our build. We want to make sure that all of our tests pass and that our code lints successfully, and then we're calling the build HTML step. As you can see, I'm just using Babel Node to run build HTML, the file that we just set up to transform our HTML file for production. Now of course I'm using Babel Node because we wrote this in ES6. Babel Node will transpile down to ES5 so that Node will be able to parse through it even if you're not running the latest version of Node. When we look at the actual build step, we can see that we're calling build.js. And remember, that file will run our Webpack build and generate our file bundle.js, as well as extracting CSS into separate files. And finally, post build will run after build, which will open up our disk server so that we can see the results of our work. Now that we have all of our scripts set up, we're going to give this a shot. So let's try running our production build and see if anything's broken. So let's run our production build, and we'll do this by running npm run build. And we'll pay attention to our output here. We can see that it's removing the disk folder and recreating it. We've run all of our tests. Now we're running ESLint, and it looks like I have one error. Index.html has been written to the disk folder as we'd expect. And now it's generating the minified bundle using Webpack. And we put out this nice message because it does take a few seconds. It's a lot of JavaScript being processed and minified. And this is really why we only want to do this for production and not development. Now in the browser, if we open up the DevTools, we can go over to the network tab and we can reload the page again. And wow, we see this huge improvement. We're dropping down from 4.8 megabytes to 244 bytes. Now, this is a huge reduction. This is especially impressive when you consider that there are still other tweaks that we can make to drop this further. There are a few things that I included to speed up our development that aren't really essential, such as Babel Polyfill, Toaster, jQuery, and Bootstrap. You can even take this a step further and drop React Router and roll in your own simple routing setup. Now, there's no way to get near this number with things like Angular 1, Angular 2, or Ember. So this lightweight result is a clear benefit of choosing focused libraries like React and Redux.